In our previous lesson, we saw about VMware vSAN that can be used as a virtual data store for storing VMs. vSAN use the local attached storage devices from each bare metal instances. So this brings in a challenge in terms of scaling the storage capacity. If you need additional capacity, you would always need to provision additional physical bare metal instances. Oracle Cloud VMware solution gives you further storage options, and the iSCSI-based block storage is one of them. Block storage can be configured as part of provisioning the SDDC through the OCI UI. The iSCSI block storage use remote NVMe drives, and it gives you a persistent, durable storage. There are 3 data copies maintained in each availability domains, and encryption is enabled by default. You are provided with 1 petabyte volumes for each vSphere cluster, and you can also dynamically adjust IOPS for those volumes. The next storage option is the NFS-based file storage. File storage can be configured up to 8 exabytes. There are multiple marketplace options, and for example, the CFS appliance could be used, or the Oracle Linux storage appliance that can be mounted as a data store for deploying virtual machines. We've been talking about bare metal instances, but what are the different shapes or compute shapes that are supported in OCVS? OCVS supports Intel Xeon-based dense I/O shapes. It is an example of the configuration used by the shape. We are not going to dive into those specifics and the configuration numbers, but just keep in mind it is an Intel dense I/O 252 shape. AMD processors are also supported, and here is a configuration supported by the AMD-based dense I/O E4 shape. There are also standard compute shapes supported. The standard shapes gives you more flexibility in terms of provisioning smaller configurations, and that helps you to scale vertically and horizontally. Intel Xeon-based standard 2 is supported, and here gives a configuration. Standard 3 version of Intel Xeon is also supported, and then the AMD-based E4 standard is also a supported compute shape configuration. OCVS brings in a new feature that it can now offer multi-clusters. What does it mean? As you see in the diagram, you can create multiple vSphere cluster with each containing specific compute shapes, and also you can mix and match different compute shapes on vSphere clusters within the same SDDC. What are the use cases of using multi-clusters? You can use it for migrations and workload separations. You could use it for migrating the entire on-premises workloads and then separate those business-critical workloads from non-critical workloads. Multi-cluster SDDC can help you to optimize your licensing cost. For example, you can create a dedicated cluster for your database workloads and license only the cores that you need. Some compliance regulations require certain types of workloads to be isolated from other workloads. Multi-cluster SDDC can help you to meet these compliance requirements. With multi-clusters, you can scale out host beyond limits. Previously, you could scale SDDCs to a maximum of 64 hosts if you're using dense I/O compute shapes. But with the introduction of multi-clusters, a single SDDC can scale up to 384 bare metal hosts. With the multiple cluster SDDCs, you can easily deploy and manage different CPU-based clusters within the same SDDC, and this is going to help you with simplifying day-to-day operations, saving time and resources. Let's look into some of the factors that you need to consider while choosing a compute shape. The first one is determining the use case. Cloud migrations is a use case. Disaster recovery is also a use case. We will be looking at a lesson that covers some of these use cases. Licensing requirements is another key factor. There are apps that need specific CPU types or certain number of cores on the physical server. The total vCPUs, virtual CPUs, memory and storage that you require for the workloads needs to be factored. We saw in our previous lessons how to calculate those resources and compare it to the physical infrastructure. Growth projection is a key factor, like forecasting how much compute resources are needed in a future point of time. There could also be ISV specific requirements to be considered, and then also the migration methods. That means there could be resource specific needs to be factored for small and large scale migrations. So that's all in this lecture. We saw the different storage options with iSCSI block and file storage supported for OCVS, the different compute shapes supported with dense IO and standard shapes. We also learned about the new feature, the multi-cluster SDDCs that you can create. And then we referred to some of the factors to consider while choosing compute shapes. Thank you for watching. Hello and welcome. We will learn about designing the target OCVS environment and deploying an SDDC for migrations. To create an SDDC, we start with choosing the region. The region is where you want the apps to be accessible with reducing latency, and typically it depends on the business needs. Then you choose how many physical bare metal instances are required, and these are the host installed with ESXi hypervisor. The shape of those instances should be chosen, and that would define the required CPU and memory configuration. The VMware vSphere product version should be selected. Storage types, whether you wanted to use a vSAN or a block storage for storing the VMs. This would again depend on the type of compute shape chosen. In the next step, you define vSphere clusters. There are multiple factors on choosing these clusters. We saw them in one of our previous lessons. The underlying VCN, the virtual cloud network, and subnets should be selected. This would be used for both management VMs and workload VMs. The license edition for hybrid cloud extension is chosen, whether you wanted to use the advanced edition or the enterprise. And it again depends on specific features, like for HCX migrations. And then the pricing interval commitment, it is selected either hourly or monthly or 1 year or 3 years. Let's learn about some of the design considerations to deploy a highly available SDDC. Starting with the compute, a compute represents the CPU and memory. And based on your on-premises, you could choose the total number of hypervisor nodes required in your architecture. As an example, OCVS provides 3 to 64 node vSphere cluster. Remember, 64 host is the maximum if you are using only dense IO shapes within that cluster. There are more scalable options if you are using a mixed shape cluster. High availability of these compute nodes are achieved through the OCI's fault domain architecture. When you provision the SDDC, these compute nodes are placed in different fault domains, and that gives the first level of high availability to your compute instances. vSphere Cluster HA or vSphere High Availability is another feature, and that can also be enabled to protect VMs running within the cluster. A VCN represents a traditional networks with all the firewalls, the gateways, and that is your underlay network for your SDDC. NSXT is the network deployed on top of VCN, or we call it as the overlay network, and that has got few components installed as part of SDDC provisioning. NSX Manager gives you a graphical user interface for managing virtual networks, and then the NSX Edge that can be used as a virtual router for VM traffic. You can factor vSphere Cluster HA function for the high availability of these NSX components. Since NSX is an overlay network, it depends upon the underlay VCN. VCN by itself gives a highly scalable architecture, so both VCNs and NSX together They provide a greater extension for SDDC to scale up networks. The bare metal compute is backed up by physical network adapters that gives higher bandwidth for your virtual machines. The next building block in an SDDC is the storage. Let's look into how the storage solution can offer high availability. VMware vSAN gives an inbuilt data store for deploying or migrating the VMs. vSAN uses an all-flash NVMe solution that are attached directly to the bare metal instances. vSAN implements a concept called storage fault domains, and it is different from the OCI fault domains. With using vSAN fault domains, you can ensure there are multiple replica copies of the storage objects distributed across those domains. We also learned that vSAN storage policies are used to determine the high availability of individual VMs. And in addition to vSAN, OCVS supports block storage that gives you persistent and durable remote NVMe drives. There are multiple data copies maintained in each availability domain, so that also gives high availability. NFS-based file storage could also be configured. There are high available storage options like the ZFS HA and the Oracle Linux storage appliance configured as a data store for the migrated VMs. The most important setup with cloud migrations is about connecting between on-premises and OCVS. OCI Fast Connect is a dedicated network link that gives you a higher quality of service. And through Fast Connect, you can set up a lower latency, higher bandwidth connectivity link between the on-premises and OCVS. The bandwidth should be a minimum of 1 Gbps, or it could be 10 Gbps for quicker migrations. VMware HCX or Hybrid Cloud Extension gives a secure connectivity with providing a set of virtual appliances, and that helps to configure site pairing between those environments to support migrations and DR operations. As part of provisioning an SDDC, it creates a set of VLANs. A VLAN is represented as an object within a VCN. The SDDC uses these VLANs to segregate traffic for different purposes. These are a few VLANs that gets created. The NSX Edge Uplink 1 is used for north-south traffic, like the internet communication for the VMs. The NSX Edge Uplink 2 is reserved for future use, and it could be used for external facing applications on the SDDC. NSX Edge VTEP is used for sending the Geneve encapsulated traffic. The term VTEP stands for Virtual Tunnel Endpoints. It is responsible for encapsulating and decapsulating network traffic as when it traverses between the underlay networks and the NSXT overlay network. NSX VTEP VLAN is used for the encapsulated virtual machine traffic that flows between the hypervisor host. We call this traffic as the east-west traffic. Then you have separate VLANs for management traffic, like for vMotion, vSAN, vSphere, HCX, and then for the replication traffic from HCX. Looking into some of the characteristics of VLAN, each VLAN is assigned with a VLAN ID. And these VLAN IDs are local to the VCN. So that means if you configure the same VLAN ID on a different VCN, it is still considered as a different VLAN domain. The purpose of using VLANs in SDDC, these VLANs would partition the VCN into different layer 2 broadcast domains. So that means each VLAN has got a routing table, it has got network security groups associated to it. So if you're using an existing VLAN, you need to make sure to update the routing tables, the network security groups to allow traffic to flow between the components. With the use of these VLANs, the SDDC can segregate traffic depending on each purpose. Wrapping up, we learned about how to determine the target OCVS environment, the design considerations for creating a highly available SDDC environment, the connectivity between on-premises and OCVS, and concluding with the purpose of VLAN broadcast domains in SDDC. That's all in here. Let's now move on to our next lesson. Hello and welcome to this demo. I'm going to show you the SDDC, the Software Defined Data Center in Oracle Cloud VMS solution, how to create it, some of the products that are part of the SDDC. So first step, log into the Oracle Cloud UI and make sure you have selected your region. So I've chosen the Australia Southeast Melbourne region, and then click on the top left burger icon, click on hybrid, and then software defined data centers. I have an SDDC already running in active state. So let's proceed to create a new SDDC. Let's name the SDDC as SDDC-1. Choosing my compartment as my demo. HCX stands for Hybrid Cloud Extension. You have, by default, it is enabled. You have got two license option. One is advanced license and another one is enterprise. So we will come back to this selection later after we choose the compute shape, because choosing the compute shape is going to override this selection. So for now, let's keep it advanced and scroll down to choose the VMS software version. So there are a few versions that you can choose here to deploy. You can select the 6.5 or 6.7 or 7.0. So let's go with the latest 7.0 update 3. Scroll down to the pricing interval commitment. Again, we will come back to this pricing selection. For now, let's leave it the monthly commitment. And as I mentioned, the pricing interval commitment have certain minimum requirements in terms of usage commitments. So for example, the hourly commitment will have a minimum of 8 hours of usage to be committed, and monthly commitment will require at least 1 month of usage. So let's proceed to confirm the pricing interval for now and scroll down to the ESXi host section. And this is where you choose the physical servers for your ESXi. And by default, the bare metal dense IO 252 servers have been chosen. Standard shapes are also supported. So let's change the shape to a standard shape. And with choosing the dense IO, you have the option to use the VMware vSAN as your hyperconverged data store for your VMs. And if you want to use a block storage, you need to use, for now, you need to use the bare metal standard shape. So let's choose or select the bare metal standard 252 shape. And it gives you a warning message that it is going to override some of the selections that we made previously. So let's click on override. And if you scroll up, the HCX license have been changed to enterprise license, and with choosing standard shape, there is a need to use the enterprise license. And then the pricing interval commitment have also been changed to hourly commitment. So let's leave it as it is, and then scroll down to the next section. So for a production usage, there are at least a need of 3 ESXi hosts that you need to create in the vSphere cluster. You also have a single host SDDC option for non-production. For example, if you want to test out the SDDC features, you can choose the SDDC, the single host SDDC. For now, let's choose the 3-host cluster. You can enable a shielded instance, which use a secure boot image for your ESXi host. Let's leave it disabled for now. Capacity types. There are 2 capacity types: on-demand capacity and capacity reservation. Let's leave it on-demand capacity for now. OCVS gives you access to your ESXi host, especially the root access. So you need to provide the SSH keys where you can authenticate into the ESXi host. So I have copied the SSH keys here. So let's quickly copy and paste. And click on next. So the next step is to choose your networking. So you need to select under which VCN you are going to create this SDDC. So I have a few VCN here, so I'm going to select one of them. You have the option to create a new subnet and VLANs, or you can use an existing subnet and VLAN. For now, let's create new subnets and VLANs with selecting this option. And under SDDC networks, there are two networks. One is for the management and another one for the workloads. So we need to give a CIDR block which doesn't overlap with the VCN subnet. So let's create an SDDC CIDR block for the management components. Scroll down to the SDDC workload network, and the SDDC workload network used the overlay network in NSXT. So whatever CIDR block that you create or you assign here will be created in the NSXT manager. We'll be having a different demo lesson on how to create that in the NSXT manager. But for now, let's just create a new CIDR block for the workload network. Click Next. In the data store section, there are primarily two data stores that you can use, one for management and another one for workloads. For management purpose, you are provided with an 8 terabyte management LUN, and for workload data store, you can choose to create a block volume. So let's create a block volume here. Let's name it as ISC for now. Scroll down to choose the encryption. Let's encrypt using Oracle Managed Keys and click Submit. So you have got two data stores here. One is the 8 terabyte LUN for management components, and another one 6 terabytes for your workloads. So let's proceed to click Next. You can also integrate event service for creating any automated actions based on state changes of your SDDC or ESXi host. Let's leave it disabled for now. And in the next step, we are going to review all the information that we provided so far, and we'll proceed to create the SDDC. So scroll down to see all the information in here. We chose the VMware version 7.0 update 3. We have the hourly commitment. Number of ESXi hosts is 3. We use the bare metal standard 252 shape. And then all the way down, networking, we chose both two networks for SDDC management and the workloads. Then it creates a set of VLANs, and we saw the purpose of using some of these VLANs in our slideware lesson. So for example, the uplink, the NSX Edge uplink one here, and then some of these management VLANs used for some of the management traffic. Right. So scroll down further to see the data stores here. We have two data stores that here we created the ISC data store for the workloads. Notifications were disabled, and now let's proceed to create the SDDC. The SDDC provisioning could take about 1 hour to 2 hours. You can see the state of this SDDC, which is creating at the moment. So let's close this page for now, and let's come back to this the SDDC page later. The SDDC creation is now complete. You can see the status is active. Now there are a set of configuration that you can do through this UI. And for example, you can configure network connectivity to your on-premises network. You can also configure the connectivity to Oracle Cloud Services. Then you have the connectivity to the internet through NAT gateway, and also connectivity to the VCN resources. We'll be seeing some of these settings in our next lesson. We'll also deploy a workload into this new SDDC environment and use some of these networking services. So that's all in here. Thank you for watching.
Welcome back to this module on designing a hybrid cloud. OCVS is a hybrid cloud. This means you can enable a connection between the on-premises to the SDDC environment created under the Oracle Cloud Infrastructure. There are a few configuration requirements to achieve a hybrid cloud. The first configuration is the Fast Connect, a dedicated higher bandwidth network links of 1 or 10 Gbps providing a higher quality of service. This is a connection with lower latency and provides 99.95% of availability. After the Fast Connect link has been provisioned, the next configuration is to deploy the HCX component. HCX is a set of appliances that provides a secure connectivity between the environment to support use cases like migration and DR. There are primarily two components of HCX that we start with: the HCX Manager and HCX Connector. The HCX Manager and Connector together builds the service mesh. A service mesh is built using a set of appliances deployed which creates an effective service configuration to be used by the source and destination. HCX Interconnect is a mandatory appliance, while HCX WAN optimization, network extension, and all other appliances are optional. Let's look into the HCX Manager and its properties. As part of SDDC provisioning, this would deploy the HCX Manager appliance and it is licensed along with other management VMs. There is a one-to-one mapping and require one HCX Manager per SDDC. The OCVS environment where the HCX Manager is deployed acts as the target for site pairing. Site pairing is establishing the connection between the environment for management, authentication, and running the HCX features. The service mesh of HCX Manager is considered as the tunnel receivers. Now let's look into the HCX Connector. The connector is always the source for site pairing, and it is paired with the HCX Manager, which means it cannot pair with another connector. The HCX Connector is licensed based on OCVS SDDC deployment. We will look into that configuration later. In this case, the connector service mesh are considered as the tunnel initiators. These two integrated components together builds the service mesh with a set of features like migrations with vMotion, disaster recovery, bulk migration, OS-assisted migration, traffic engineering, etc. Let's look into the HCX Layer 2 extension configuration. There are some prerequisites to make HCX work. The on-premises environment should be configured with a distributed virtual switch. A dedicated private network should be established using Oracle Cloud Fast Connect. And finally, the required routing configurations and security rules for VCN and on-premises should be configured to allow the communication. As part of the preparation, the first step is to download and deploy the HCX Connector appliances at on-premises. Now remember, HCX Manager is already deployed as part of OCVS SDDC deployment, and the connector is to be downloaded from the HCX Manager interface, and then deploying it on-premises, followed by activating the product using the key provided by HCX Manager. Once the product is activated, the next step is to configure the site pairing with entering the IP address and other authentication details. The site pairing establishes the connection for management, authentication, and orchestration for HCX services across both the environments. A compute profile needs to be created, which is a container of the compute, storage, and network settings used to deploy the HCX appliances. A network profile is part of the compute profile, and it is an abstraction of network properties like distributed port group or NSX logical switch or any of the other layer 3 properties of that network. In the next step, a service mesh is created, which is the HCX service configuration to be used by both on-premises and OCVS. And finally, the last step is to select the on-premises VLANs to extend, including other properties like the gateway, the destination's first hop router, etc. And with that configuration, your VLANs are now extended from on-premises to OCVS. After the migration of VMs, the network settings of those VMs needs to be changed to that extended VLAN port group. Mobility Optimized Networking is an HCX enterprise feature. This feature allows you to route the traffic of a migrated virtual machine within OCVS without tromboning. So what is a network tromboning? Tromboning occurs when all the traffic from the workloads on an extended network at destination is routed through the on-premises router gateway. This feature ensures that the traffic remains symmetric and it uses an optimal path to reach its destination. With Mobility Optimized Networking, an NSXT Tier 1 gateway is connected to perform the local routing task. All this optimized routing can be configured in an automated way. Mobility Optimized Networking allows policy-based routing. The policy routes means which traffic needs to be routed through the source gateway compared to the traffic routed through the cloud gateway. When the destination network for a traffic flow is not within the STDC NSXT Tier 1 router, the Mobility Optimized Networking policy is evaluated. It is evaluated in a way that if the destination IP is matched and configured to allow in the policy, the packet is forwarded to the on-premises gateway using the HCX network extension appliances. If the destination IP is not matched or configured to deny in the policy, the packet is forwarded to the STDC Tier 0 gateway to be routed. There are different ways to migrate virtual machines to Oracle Cloud VMware solution using HCX. HCX Advanced Edition gives a few migration types, starting with the cold migration. A cold migration is done with VMs powered off, and the data transfer is done using the NFC, the Network File Copy Protocol. The migration is cold, which means there is a downtime for the VM. The second type of migration with the Advanced Edition is the HCX vMotion. vMotion transfer captures the virtual machine's active memory, its execution state along with its IP address and MAC address, and transfer to the destination. It is referred as the live migration feature of VMware, and so there is no downtime for the VM. The next migration type is HCX Bulk, and it uses HBR, host-based replication method. This is done by replicating several number of live virtual machines to the target site. The replication process makes an initial full sync of the VM in the target site, and then the delta and the change blocks are replicated. Once the delta replication is complete, a switchover is triggered which has a minimal downtime for the running VM, and so it is called a warm migration type. HCX Enterprise provides additional migration features like OS-assisted replication. This is done through an agent deployed on the guest operating system of the VM, and it has minimal downtime, so it is a warm migration type. Replication-assisted vMotion is designed for massive migrations, and it is an enhanced version to the HCX Bulk migration. It works with a combination of HBR and vMotion working together. In this migration type, the difference is that the last switchover is done through vMotion, and so there is no impact to the running virtual machines. So it is considered as a live migration. To wrap up, in this module, we learned the configurations that make OCVS a hybrid cloud. We then looked into the HCX components like HCX Manager, the connector, and the appliances like interconnect, WAN optimization, and network extension, forming together a service mesh for the hybrid cloud features. Then the configuration of Layer 2 extension using HCX, and also some of the enterprise features like Mobility Optimized Networking, allowing you to choose the optimal network path for the migrated workloads. And finally, the different migration types with vMotion, host-based replication with HCX Advanced and Enterprise editions. So that's all about this module. I hope you enjoyed the session, and thank you for watching.
Hello and welcome. We are going to learn about a new migration service called Oracle Cloud Migrations. This is Jason on the left. He's a business owner and he runs his own on-premises data center. He's got a few requirements to run and manage his apps. So he has chosen a VMware software-defined data center platform to host these application virtual machines. So here is a problem. His data center lease is expiring soon and some of his infrastructure components are reaching end of support. This made him think about migrating into Oracle Cloud Infrastructure so he can quickly exit his data center. But he wasn't sure how to migrate these apps into OCI, so he reaches out to his wider team for any suggestions. Now this is Emily. She's a cloud architect. She has got two different options. In the first option, he could move those VMs as it is into Oracle OCI, Oracle Cloud VMS Solution, or OCVS. The underlying platform of OCVS is same as a software-defined data center, so the entire VM can be simply moved. We usually call this method of migration as rehosting. The second option was to migrate his VMs into OCI using a managed service called Oracle Cloud Migrations. Migrating a VM means the data from the source VM will be replicated over to a new native compute instance of OCI. And we call this option as replatforming. So now Jason decides to choose the second option, which is using Oracle Cloud Migration Service, because there are some benefits he can achieve. He can migrate his VMs in an automated way with lowering the cost. He would be able to test out each migrations. He would be able to expand integrations with all other native OCI services. And then finally, he can reduce the overhead of infrastructure management. What is Oracle Cloud Migration Service? It is a centralized service used for migrations. It gives you an end-to-end self-service for migrating application workloads from an external environment into Oracle Cloud Infrastructure. Let's look into some of the features of this service. First of all, it enables you to identify and discover workloads that are hosted in an external environment like on-premises. Once you have discovered these workloads, you can then group and organize them for migration. The next feature is about projecting cost. OCM service gives you cost estimations like how much it is going to cost to run these migrated workloads in the OCI environment. Replication is one of the key features. You'll have capabilities to replicate data over the network. That means you can copy the VM data from the source into the target OCI environment. And then finally, using this replicated data, you can then launch them as compute instances, which will have the same application as it was running in the source virtual machine. Quick wrap up, we learned an overview of Oracle Cloud Migration Service, the key purpose, and let's now take a look into some of the core concepts of this service. Thank you for watching. Hello and welcome. We will learn some of the key concepts of Oracle Cloud Migration Service. To begin with, these are some of the terminologies that you need to be familiar before we dive into individual lessons. OVA appliance. OVA stands for Open Virtual Appliance, and that uses an open standard for packaging and distributing virtual appliances. These appliances will have both the operating system and software bundled together as an image, and it makes easy to quickly deploy it into an environment like the on-premises. A plugin is a logical component within a software product, and that gives certain features to enhance the functionality of that product. VDDK stands for Virtual Disk Development Kit. It is a collection of utilities that are used to remotely access the storage disk of the virtual machine. It is a utility from VMware. We will be seeing more about VDDK in the coming lessons. Snapshot is defined as a copy of the virtual machine disk file at a given point of time. If you consider a running VM, there are continuous write operations happening into the disk file. So the snapshot will be a specific point of capture of this file, and all the writes up to that point will be saved into that snapshot file. We used the term replication earlier. So replication is the process of copying and maintaining data from a source environment into a target environment. Hydration agent is a terminology used in the OCM service. It is simply a compute instance acting as an agent to support the migration flow. We'll be seeing more about hydration agent later in this module. The next terminology that we will mostly hear are assets. Assets are categorized depending on the stage of the migration workflow. An external asset is a representation of an external environment outside of OCI. Here in our case, the VMware environment at the on-premises is an external asset. The inventory asset is a representation of virtual machine that are discovered from an external asset. Migration asset is a subset of inventory assets and those VMs that are selected to be migrated. There are other configuration part of migration asset, and we will see that as we go along with the next set of lessons. Target asset, that represents the target configuration of OCI native compute instance that needs to be launched as part of the final migration flow. There are a few phases involved in the end-to-end migration flow using OCM service. The first phase is the connect and discovery phase. This is where you would discover more about the VMs that are running on the on-premises VMware environment. This is done through installing and registering a remote agent appliance, and we will see them shortly in our next lesson. The second phase is about building the inventory. Once you run the discovery, this process would start collecting information from the on-premises, and it builds the inventory page listing all the inventory assets. One of the key purpose of the inventory phase is that you can annotate and group these assets based on application types based on the line of business. The third stage is about assessment and planning, and it is done through the creation of migration projects. OCM service would collect necessary metrics so that you can review and determine what configuration is required to be created on the target OCI environment. In the fourth stage, the migration kicks in through the process of replication, and the data from the source on premises or the source environment will be copied over to OCI. There is a workflow to be followed here, which we will see later. And in the final stage, you are provided with capabilities to launch the migrated resources. There are capabilities like using resource manager stacks or quickly launching the compute instances. Quick wrap up, we looked into the terminologies used in OCM, Oracle Cloud Migration Service. We also referred the different types of assets, the external asset, inventory asset, migration and target assets, and concluding with the 5 migration phases that are involved as part of the OCM service. So that's all in here. Let's now move on to our next lecture. Let's explore the first 2 phases in Oracle Cloud migrations, the discovery phase followed by the inventory. When we look at cloud migrations, there is a source environment from where you're migrating, and then there is a target environment to where you're migrating. So the picture here represents the source on premises, and in order to discover resources from this environment, we use a remote agent appliance, and that is called Oracle Cloud Bridge. Oracle Cloud Bridge can be downloaded from the console UI of OCM service, and it is available in the form of a OVA appliance. We saw the definition of OVA appliance in our previous lesson, and it is a pre-packaged image that contains the necessary discovery and replication tools. This Cloud Bridge appliance would need to be deployed on the source network, and then it is registered with the OCM service. This registration would establish the connectivity between the on-premises, the VMware environment, and OCI. One of the key purposes of CloudBridge is that it is used for discovery process that can be automatically initiated from this appliance. As part of the discovery, the discovered assets and the metadata are sent to OCM to form the inventory page. There are some prerequisites while setting up this OCB remote agent appliance. OCB requires VMware environments to be managed by vCenter. vCenter is a management software from VMware, and that is used to manage virtual machines. The second requirement is that OCB appliance should be configured with external connectivity to OCI. You should also have internal connectivity to the backend systems like the vCenter and the hypervisor host. One way of doing this would be there could be two network adapters configured with the OCB appliance, and it will help you to split the communication, one for internal communication, the VMware networks, and another one for external communication for the OCI resources. Similar to the network connectivity, DNS is also another key requirement. OCB should be able to resolve the fully qualified domain names of VMware source components like the vCenter, the ESXi hypervisor host, and it should also be able to resolve the external OCI endpoints like the cloud.oracle.com domains. Network interface configurations can be defined through DHCP, or you could use static IP addresses. The source environment becomes a configuration to set up, and we start with deploying the OCB appliance into this external VMware environment. This OCB appliance establishes the agent registration, and it enables to configure the remote connection agent. There are 3 plugins launched as part of the remote connection agent. The discovery plugin is used to search for VMware virtual machines from the source environment using specific connectors. The replication plugin manages the replication process of the source asset from the source environment into our infrastructure. The agent health monitoring plugin is used for monitoring the agent itself and also reporting the health status. The second step in the source environment configuration is the agent dependency. The agent dependency is configured with uploading a VDDK file into the object storage bucket. VDDK stands for Virtual Disk Development Kit, and it is provided and downloaded from the VMware website. VDDK is a single file that contains certain libraries and utilities, and it will help the OCM service internally to access the storage volumes of the source virtual machines that are to be replicated. And for that reason, the VDDK agent dependency is required to be completed for the replication plugin to be in active state. The next configuration in the discovery process is the asset source. Asset source represents the connectivity information that you define for a source environment. OCI Vault service is used to centrally manage and maintain secret credentials to securely access these resources. You would add username, password, those credentials for discovery and also for replication as part of the asset source configuration. Discovery schedule is about choosing at what interval you wanted to run the discovery process. As an example, you can schedule it to run daily, weekly, monthly, or yearly basis. You also have the ability to collect historical and real-time metrics from the VMs. These metrics can be used to optimize the migration process and also identifying any potential issues that may arise during the process. With configuring asset source, you can proceed to run an automated discovery. It is a simple one-click process. Discovery of the VM essentially means you are discovering the list of VMs, the associated virtual disk attached to those VMs, the network, the CPU and memory usage, metrics, and any VMware specific tags that are assigned to those VMs. In addition to ad hoc on-demand discovery, You can also run a scheduled discovery depending on the schedule that you have chosen in the asset source configuration. From discovery, we move into our next stage, inventory. Inventory is an OCI representation of those discovered assets along with its associated metadata collected from the external asset. You'll also have options to import assets from a CSV. One of the purpose of the inventory page is that you can review the details of these VMs that are discovered, and that makes it easy to decide and confirm the target shape for each VM. As an example, you can see how many CPUs are configured, what is the amount of memory, the total storage provisioned, the number of network adapters, and so on. Inventory assets are used to create migration assets in a migration projects. That means you are selecting which VMs are to be migrated into the OCI target. At this stage, you are organizing VMs with tags, annotating or grouping them based on the application or the type of function. Summarizing the overall picture of discovery and inventory together, we have a VMware-based external environment that are running virtual machines. We start with deploying an OCB remote agent appliance within this environment. The OCB agent registration creates the remote connection agent, and that has got 3 plugins: the discovery plugin, replication plugin, and agent health monitoring plugin. And then you configure agent dependencies with VDDK. In the next step, asset source is created with the discovery schedules. The credentials are stored in Vault service to authenticate and run the discovery. Once the discovery is complete, the inventory is populated with the information of the VMs that are discovered. That concludes this lesson. We saw how to discover VMs and create an inventory. Thank you for watching. Hello and welcome to this demo lesson on Oracle Cloud Migrations. We're going to look at the discovery phase using OCM service. So how to navigate into the service? Click on the top left burger icon, migration and disaster recovery, and then click on Cloud Migrations. Now, before we start configuring the OCM service, there are a set of prerequisites. And these prerequisites are in terms of configuring IAM policies, creating a few set of compartments. So to make that process easy, there is a GitHub repository where you can access through this URL here. And it does a couple of things. Now, if you scroll down, you can see there are a few resources deployed. Number one is the compartments. So there are 2 compartments that we're going to use with OCM. So the first compartment is called migration, and this is where we are going to configure the OCM service. Then we use a second compartment called migration secrets, and this is where we store the username credentials for the source environment. We use the Vault service to store these credentials, and then the OCI Vault and key that needs to be that stores the vCenter, the VMware vCenter credentials. Then we also create an object storage bucket where the service will transfer the vSphere snapshot data into the OCI environment. And then some of the service policies, IAM policies, the associated dynamic groups that are required to make sure that the OCI service components can communicate each other. So these resources are to be deployed using this code repository. So all you need is just access this URL here, click on the code button here to download the zip file, and you can apply this file as a resource manager stack in OCI to create all these necessary prerequisites. So I have created all the necessary prerequisites, all the configurations. So I'm not going to run this step again. So let's navigate back to the Cloud Migrations UI to to get started with our first discovery phase. So the very first step in the discovery phase is to configure the remote connections agent. And to configure the remote connection agent, you need to create a source environment. We will name the source environment as just the source. Make sure that we are going to create in the compartment called migration, and click on create source environment. So there are a couple of buttons here where you can download the OCB remote agent appliance. You can register the appliance. So let's click on download agent VM. And it gives you all the details on OCB appliance, the version. So in my case, I have already downloaded this appliance and kept it in my desktop. So let's close this for now. So the source environment that I'm using here is actually an OCVS environment that represents an on-premises VMware-based infrastructure. So how to deploy the appliance? Click on the cluster here, right-click on the cluster, deploy OVF template. Click next. Click next. Next. Review the details and click next. So the storage, the data store is shown here. We will choose in which data store we are going to deploy this appliance. In terms of networking, there are some prerequisites, right? So for the OCB appliance, it needs to have internal connectivity to all vCenter and ESXi hosts. And at the same time, it should also have connectivity to external OCI endpoints. In my case, I'm going to use one of the external network that has got communication to the external OCI URL, the cloud URL. And then the internal network is for the internal communication with vCenter and the underlying vSphere host. So I'm going to choose the vSphere network here. So we will leave the certificate key blank for now, and the host name can be OCB appliance, which is fine. We will leave the network properties blank, and it will take the DHCP IP. DNS is a mandatory requirement for OCB to resolve the fully qualified domain names. I'm using one of my DNS server that I've used in the environment. I'm also using an NTP server, so I'll use a public one, which is the time.google.com, and click next. So we are ready to go with provisioning, with creating the OCB appliance, and click on finish. So the appliance have been deployed. Now you can see the OCB remote VM here. We need to power this VM on. So click on the VM and then click on the power on button. We need to take a note of the IP address that is being set to this VM, the 192.168.50.106, and we will be using this IP address to register the OCB appliance with the OCM service. So let's go back to the OCM service UI and click on register agent. The port number used is 3000, so we will leave as default here and click on register agent. It opens a new tab. We will have to provide a unique name for this agent. And finally, confirm the agent registration. So once the agent registration is done, you can see there are 3 plugins here: the Discovery plugin, the Agent Health Monitoring plugin, the Replication plugin. So the Discovery and the Agent Health Monitoring plugin would become active if the communication is successful. The heartbeat is being returned as healthy, and it takes some time to get the Discovery and the plugins to be in active state. So we can see the Discovery and the Agent Health Monitoring plugins are active now. And for the Replication plugin to be active, we need the VDDK file to be uploaded into the object storage bucket and create an agent dependency for this remote connection agent. So let's go back, go to the top source environment here. Let's click on the source that we created. Scroll down to the agent dependencies section. Click on Create Agent Dependency. Now there are a couple of options here. You can choose an existing object storage bucket where you have the VDDK file already uploaded, or you can upload the new dependency package as part of this configuration, or you can select an existing agent dependency configuration. So in our case, I have an object storage bucket that's already created and also uploaded the VDDK file. The VDDK file is downloaded from VMware's website. So let's proceed to create this agent dependency. The compartment is same as migration. We're going to name it as agent dependency. We are going to select the bucket in this migration compartment, which is I have the OCM replication bucket here, and choosing the VDDK file, which is a tar.gz file. In this demo, I'm using the same object storage bucket that's been used for the agent dependency and also as the OCM replication, the replication bucket. And let's proceed to click Create. The agent dependency is active now. So let's take a look at the remote connection agents again. The replication plugin is back to active state. The next step in the discovery process is to create asset source. So let's click on asset sources under the source environment and click on create asset source. We will leave the name as default. The vCenter endpoint would be the URL of the vCenter followed by /SDK. Compartment is migration. The target compartment is also migration. Then we choose the remote connection source environment that we created. Then we choose the discovery credentials. So if you remember, we had 2 compartments. The second compartment is called migration secrets, and that is used to store the credentials for the vCenter and through the Vault service. So let's change the compartment to migration secrets and choose the Vault service. So in my case, I already have created the Vault service, and also a key has been created. We will use the replication credentials, same as for the discovery credentials. Discovery schedule, for now we will not use discovery schedule, but there is an option to create or use an existing schedule. You also have the option to enable collection of historical metrics and real-time metrics. And let's proceed to create the asset source. With creating the asset source, we are now ready to run the discovery process. We can run discovery on demand, or you can also choose to run the discovery process as based on a schedule. We didn't actually create a discovery schedule, so let's proceed to run the discovery on demand. The discovery process is completed now, and that concludes the discovery phase. We will now see the inventory phase of Oracle Cloud Migration. Thank you for watching. Hello and welcome back. In our previous demo, we saw how to run the discovery phase in Oracle Cloud Migration Service. So in this demo, we're going to look at the next phase, which is the inventory phase. So let's quickly navigate to the OCM Service UI and have a look at what is inventory phase. So let's click on the top left burger icon again, and migration and disaster recovery, and click on inventory. So as soon as we complete the discovery process, it collects the information from the source vSphere, the VMware environment, and the inventory page will be populated. So you have a summary page here, and this is all the information collected from the VMware based environment. You can see the asset classified by type. These are all virtual machines. The total memory, the consumed memory, which is approximately 200 gig. Then you have the total storage consumption, which is 2.58 terabytes. Then the total CPUs, and then scrolling down, you can see the different virtual machines classified by operating system, VMs by the vCenter version. So this is just a quick summary on what is being discovered and shown in the inventory page. You can also match this information with logging into the vCenter environment. So I have just opened the vCenter environment here. So with selecting the cluster here, you can see the amount of resources consumed. And for example, we saw this, the storage consumption was approximately around 2.2 2.5 terabytes, right? So we can review and compare with what's been discovered, and also making sure that the inventory is being updated correctly. So let's go back to the inventory page. Let's click on inventory assets on the left. So this is where we would see all the VMs that are discovered through the discovery process. And you can see the OCB remote, the remote agent appliance that we installed as part of the discovery is also being discovered. You can see a few other VMs also here. And we'll be looking at this particular workload VM to migrate into OCI. So the main purpose of using inventory is to review details, looking into what resources is being used by each VM. And that's going to help in while we create the migration project and migration plans. So let's take a look at this particular VM called workload and expand the section on the right. So it gives you all the details on what configurations the VM is using. For example, the operating system uses Ubuntu Linux. Then you have the power state is been powered on. Then the total number of CPUs, which is 2 CPUs configured. Then the memory configuration is 2 GB. The provisioned storage, the IP address of the VM, then all other the vCenter related information. So primarily the inventory phase is used to prepare for the next phase, which is the planning and assessment phase. If you want to clean up this inventory, and for example, if you don't want to migrate a set of VMs, we can delete those VMs from this inventory page. You could also leave the VMs as it is in the inventory page, because we are not making any selection of VMs, what VMs to be migrated at this stage, and that's going to be as part of the migration project. And then from here, we can create a migration project with clicking this create migration link here. You also have the option to import assets with clicking this link here. If you have a CSV file that contains all the asset information, you can upload it and import it into the inventory page. So that's a quick demo on inventory phase of OCM service. Thank you for watching. Hello and welcome back. We will now focus on our next lesson, and that is about migration projects. The stage of planning and assessment starts with the creation of migration project. Migration projects are logical containers for migration assets and migration plans. Through this migration project, we define what VMs are we going to migrate, where are we going to migrate them, what schedule are we going to use for migration, and so on. Migration assets can be referred as a point-in-time snapshot of an inventory asset and providing a replication location. A snapshot is similar to a backup of a VM that is captured at a specific point in time. In simple words, you make a selection from those inventory assets that are required to be migrated, and those assets become your migration assets. Migration is done through the method of replication. So the migration project would also need to be specified with a replication location. OCM service use an intermediate object storage bucket where the data is first copied. This object storage bucket is like a staging area where you wanted to get the data first. And from here, the data will be transferred into the next stage, and which we will see in our next lesson. Replication schedule can be chosen as part of the migration project, and here you specify how often the replication should happen. It could be configured as daily, weekly, monthly, or yearly. Migration plan is a detailed mapping of those discovered assets into target assets of OCI. You can create multiple migration plans for each migration project, and there are certain features that allows you to efficiently plan and assess the migration. The first feature is about defining migration strategies. You can choose strategies based on VM configuration, meaning it could be the actual CPU and memory configured on that VM. There are also strategy options that you can choose based on historical and real-time metrics. You can use the average or peak values of those CPU memory resources that are consumed. It could also be a certain percentage of either CPU or memory resources. Target asset is the target configuration of the VM that is represented in the OCI compute service, and that is generated based on the selected strategy. For example, again, there are different compute shapes available in OCI compute service, and depending on the resource usage, a target asset mapping would be created. Target assets can be automatically chosen, or you can manually configure target assets to meet specific performance or cost needs for the migrated VM. VMs use different CPU architectures. So one of the purpose of the migration plan is to check the asset compatibility with OCI compute shapes, depending on the architecture. And then cost estimate is a critical one. OCM service considers the cost of the recommended compute shape and size of the volumes that are to be used by the VM. The cost estimate would let you know how much approximate it is going to cost to run those instances in OCI, and so that you can make decisions to modify that into another shape with a lower cost. Let's bring migration assets and migration plans together to form migration project. Migration assets are the selection of what assets are going to be replicated or migrated. You would then choose the replication schedule and a replication location, that is the object storage bucket. And then the migration plan is where you select a strategy, whether to factor recommendations based on the actual VM configuration or maybe using the resource usage of each VM. Based on that strategy, a target asset is selected with the recommended shape. And this is where you can review the compatibility assessment results. There are also ways to manually configure these target assets to meet specific performance needs for the migrated VM. And then finally, migration plans allows you to review cost estimate for the chosen target asset configuration. To wrap up, we learned about migration project. It is a logical container for choosing migration assets and migration plans. So that's all in here. Thank you for watching. Hello and welcome back. We will look at the next phase in OCM service, which is the planning and assessment. So let's quickly navigate back to the OCM service UI. And this time we will click on migrations. Click on create migration project. We will create a simple migration project. So let's proceed to click create migration project. Let's leave the name as default and click on create. So a migration project have two main components. One is migration plans and migration assets. We will start with the migration plan. We will leave the migration plan name as default. The compartment is migration. We're going to create it under the same compartment migration. And migration strategies is one of the main function in a migration plan. So migration strategies could be based on resource type, whether you could choose CPU or memory. For now, let's go with the default one. You can choose a strategy type. You can choose the configuration same as the source with choosing just as it is, or you could choose the average utilization or peak utilization, or maybe a percentage of the resource utilization. For now, let's use as is, which will take the exact configuration of the VM running in the source. Under the target environment, and this is where we are going to choose the VCN and the subnet where we are going to migrate this virtual machine. We have selected the VCN and the subnet, and let's proceed to create the migration plan. The migration plan is created. So now let's go back to the migration project and select the migration assets. Click on add migration assets and add from OCM inventory. So these are the VMs that has been discovered and added into the inventory page. So we are going to add just this workload virtual machine part of this migration asset and migrate as an OCI compute instance. So let's click on add migration assets. The next step is to choose the replication location. So we will use the same replication bucket that we use for the VDDK bucket. So that's the OCM replication bucket here, and click on submit. We need to select the replication bucket and click on submit. The migration asset is active now. So let's go back to the migration plans. As you scroll down to the summary page of migration plan, you can see and review the asset compatibility. The compatibility is high with no warnings or errors being found. You can also review the cost estimation. There is a comparison between AWS and OCI. So this is the total monthly cost that's been compared to run this instance, to run the instance in OCI. In the migration plan, we can also see the target asset configuration. So if we scroll down on the left, we can see target assets. So here the workload VM is mapped to standard E4 Flex, and the new compute instance will be based on this shape. We are now ready to start the replication. Let's go back to the migration project. You can replicate based on a replication schedule, or you can click on this replicate button to start replication immediately. So that concludes this lesson.
In our next lesson, we will see how to run this replication and launch this as a compute instance in the target OCI environment. Thank you for watching.
Welcome back. We will go through our final migration stage in OCM service, replicate and launch instances. We saw in our discovery lesson, Oracle Cloud Bridge has got a few plugins, and one of them is the replication plugin. This plugin is responsible for triggering the replication process, and it is integrated with the OCM service. The way it is done, the service would initiate a copy of virtual machine snapshots, and it drops that into the object storage, the intermediate object storage bucket, depending on the replication schedule. There are two types of replication that we are referring here. The first one is called full snapshot copy. Full snapshot is an entire copy of a virtual machine that is captured at a specific point in time. As when you initiate the migration for the very first time, it replicates the full snapshot copy of the VM. The second type of replication is called the incremental transfer, or you can refer that as CBT, change block tracking. This is a VMware feature that identifies those blocks of data that have changed on the virtual machine. To enable incremental transfer, there is a manual configuration change to be done on the source VM settings with adding certain configuration parameters. It is a VMware specific settings change, so we are not really covering what are those specific changes. There are a few knowledge base articles to show how to configure it. And with incremental transfers, you are copying only those change blocks that are written to the source virtual machine disk once after the full copy snapshot has been transferred. Replication bucket is where the data is copied first, and that is what we referred as the intermediate object storage bucket. Hydration agent is simply a compute instance, and that gets spinned up during the migration process. It is simply used for transferring the data from the replication bucket into a replicated block volume. This hydration agent will be automatically provisioned, and it gets automatically terminated once the transfer process is complete. Now we have that replicated block volume, and the next step is to launch the target compute instance. A resource manager stack could be generated to launch the target instance from the migrated volumes, and this resource manager stack contains Terraform scripts with all the necessary variables depending on the migration plan. The replicated boot volumes are also modified automatically in order to do a successful launch of the compute instance. And as part of launching those instances, you could use the migration plan created in our previous stage for testing purposes, testing the VM migration, and also for the final cutover of the migrated VM. Bringing replication and launch together, OCM service access the VMware infrastructure environment through the replication plugin. The storage boot volumes and data volumes are replicated into the object storage bucket, and from here the data is transferred into storage block volumes with the help of the hydration agent. For replication, you could also configure incremental snapshots to be copied on a defined schedule, so that only those new changed blocks are transferred after the first full snapshot copy. Once the replication is done, we are ready to launch the instances. The boot volumes are modified to ensure a successful boot up. A resource manager stack could be generated to launch those target compute instances from the replicated block volumes. And finally, you can choose separate migration plans for testing the migration and also for the final cutover of the VMs. So that concludes this lecture. We learned about the replication process, how it is initiated, and how to launch those volumes into compute instances. Thank you for watching. Hello and welcome back. So here we are going to see how the OCM service is going to run the replication process and launch the migrated virtual machine in the OCI compute service. Let's navigate back to the OCM service UI. Click on migrations. So in our previous demo, we created a migration project, as you see here, and we didn't actually create a replication schedule. So, but we can always create a replication schedule through this UI. Click on replication schedule, and there are a few options here with the schedule type. You can replicate daily or weekly, monthly or yearly. You can also choose the start time here when the replication should be initiated. So we are not going to use a replication schedule in this demo, and we are going to initiate the replication process from the migration project. So let's navigate back to the migration project. Click on the migration project that we created in our previous lesson. We will take a quick look at the workload that we are going to migrate with accessing the VMware vCenter environment. We have chosen the workload VM here to be migrated. So if you click on this launch console, we should be able to launch the VM console. We will do a listing of the directory here. And there are two types of replication that we spoke about. Number one is a full snapshot copy, and it takes the entire capture of this virtual machine at a specific point of time, and it transfers into the target replication bucket. And then the second type of replication is called the incremental transfer. And what that means is there is a continuous write operation happening to this VM. As for example, if you create a file here, only that block of data can be transferred in the subsequent replication cycles. And we refer that replication as the incremental transfer. There are a few settings, configuration changes that is required to enable incremental transfer. It is also called as change block tracking. It is a feature from VMware. This is a KB article from VMware, so you can refer to this article on what changes, what configuration parameters that you need to change on the VM settings. So in this demo, we are not going to use the CBT, the change block tracking, or incremental transfer. We will be using the full snapshot copy. So going back to the workload UI, so there are a couple of files here. As you can see, the Linux agent installer script file here. So let's have a look here and then go back to the migration project UI and replicate this virtual machine. So I'm back in the migration project UI. Let's click on the replicate button. The replication process has been initiated. There is a workflow that OCM service follows to replicate the virtual machine. So in the source VMware environment, it takes a snapshot. The snapshot is transferred into the replication bucket. And then there is an hydration agent, which is a compute instance that gets spinned up automatically. And that hydration agent is responsible for transferring the data into a replicated block volume. The hydration agent will be terminated automatically after this process. So all these processes automated. We don't need to do anything in the UI at this stage. If we go back to the VMware environment, we can see a few tasks that is being completed. It created a virtual machine snapshot. It also then removed the snapshot after it's been transferred over to replication bucket. So let's go back to the OCI page and look at the object storage bucket, whether the volume has been transferred. And here you can see there is a folder created, and this is the data which is being dropped into this object storage bucket. So how do we monitor this migration, this replication process? So going back to the OCM UI. The migration project. If you click on this work request, it gives you the status of replication. So right now it's still in progress, and this is where we can track the migration, and once the migration is complete, we should be able to mark it as complete. The replication process is complete, is 100% now. To generate an RMS resource manager stack, we will go into the migration plan. Click on the migration plan we created and generate RMS stack. Once after generating the RMS stack, we are good to deploy or launch the migrated virtual machine. So let's click on deploy RMS stack and confirm to deploy it. The compute instance will be deployed through this RMS stack. And if you scroll down to resource section, you can see all the created resources. So if you click on it, you can see the workload instance have been created. Let's quickly check the IP address of this VM and log into this particular instance. We'll try to log in using SSH. The data has been transferred to this new compute instance. So we have now seen the different phases in Oracle Cloud Migration Service, starting with the discovery and inventory, planning and assessment, and finally the replication and launch the compute instance. So that's all in this lecture. Thank you for watching. Hello and welcome back to this lecture. We learned the different phases of OCM service, and let's now stitch all of these together and see an end-to-end workflow of migrating on-premises workloads using the service. On the top left, we have the external environment, and that is running VMware vSphere, and it is considered as the source. On this external environment, the Oracle Cloud Bridge remote agent appliance is deployed, and it is registered with the OCM service. With this registration, the remote connections agent becomes active. There are mainly the discovery plugin, the replication plugin, and the agent health monitoring plugin. The replication plugin requires the VMware VDDK file accessible through an object storage bucket. This step is also called as the agent dependency configuration. Remember, we have two object storage locations, one for the VDDK agent dependency and another object storage as the replication location. Then we create the asset source that I've got the migration credentials stored in the Vault service. The asset source is where you start the discovery process. You can discover on demand or on scheduled intervals, and that gets the discovered data into the inventory. Those inventory assets are used for review purposes, grouping and organizing them based on the application function. Then the migration project is created with using which inventory assets are to be migrated and an object storage bucket as the replication location. Both of these selections becomes part of your migration asset in a migration project. Migration plans would have the migration strategies defined so that the target asset will be recommended based on that strategy. These strategies could be chosen on CPU or memory and then selecting a strategy type. The strategy type could be the same amount of CPU or memory resources used by the source VM, and that to match with the target asset. It could also be the peak utilization or an average or percentage of the CPU memory resources. And in this migration plan, you would check the asset compatibility and also review the cost estimations. Then in the next stage, you can start the replication immediately or replicate based on a selected replication schedule. The replicated data is copied into the replication object storage bucket. And during this process, the hydration agent transfers this data from the replication bucket into a target block volume. And in the last step, a resource manager stack would be generated to launch a compute instance from the block volume. Let's see a few examples of this migration workflow that is driven through the OCM Service UI. Here there are 4 VMs in the source VMware environment. Asset source is created, the source VMs are discovered, and it shows up in the inventory as asset 1, 2, 3, and 4. For asset 1 and 2, a migration project with having a migration plan is created. Migration plan have got recommendations on what target assets have to be used. So asset 1 is mapped to target asset 1 and asset 2 is mapped to target asset 2. Once the target assets are reviewed, the replication process is initiated at this stage. And then followed by replication, a resource manager stack could be generated from the migration plan. In the last step, the resource manager stack is applied, and that will launch them as compute instances. In the same way, for asset 3 and 4, migration project B is created, but here there are 2 migration plans. Each migration plan could be using different strategies, so you'll have multiple target assets with different compute shapes. The remaining steps are same as before. Resource manager stack is being generated for each migration plans. One could be used for testing, another one could be used for production, and then finally launch those instances on separate VCN subnets. Let's do a quick wrap up. We summarized the components involved in OCM. We also referred to an end-to-end workflow of migrating on-premises workloads, how it is initiated and executed using the OCM service. So that concludes this lesson. Thank you for watching.
Welcome to this lesson on data transfer service. Let's begin. Before we look at the data transfer service in detail, let's first look at the 2 different strategies, which are offline and online migrations. So moving data over the public internet is not always feasible. Why? Because at times the network connectivity can be unreliable, and sometimes there can be long transfer times. Similarly, there can be scenarios when the data to be migrated is large and the WAN bandwidth is low. So for these scenarios, OCI offers offline data transfer solutions that lets you migrate data to OCI. And when your bandwidth is high enough to support ingest over WAN, you can use a storage gateway for secure online data ingest. In this slide, we will look at an example of how long it takes to migrate datasets of different sizes, depending on whether we are migrating datasets online or offline. So you see, there are different dataset sizes: 10 terabytes, 100 terabytes, 500 terabytes, and 1 petabyte. And we also see how much time it takes to transfer the data depending on the available bandwidth. For example, if the dataset size is 500 terabytes and you have bandwidth of 1 Gbps, to a fast connect connection, still it can take around 50 days. But if you use data transfer service, it will take around a week. So for the scenarios where you see the color coded numbers, it makes sense to use the offline data transfer options like the data transfer service. Now let's look at data transfer service. Oracle offers offline data transfer solution using which you can migrate data to OCI. Suppose there is some data which is currently in OCI. You also have the option to export it to your data center offline. So you can move petabyte scale datasets to or from OCI in days instead of weeks or months. You can transfer data fast and cost effectively with multiple options. For some customers, OCI offers the option to migrate their data on secure, high capacity Oracle supplied storage appliance at no cost. Customers also have an option to send their data as files on encrypted commodity disks, which are then transferred by Oracle operators to designated customer object storage tenancy. After the transfer is done, the disks are going to be shipped back to the customer. When you transfer the data, there is support for both standard tier and archive tier. Let's look at the three types of data transfers that are supported in data transfer service. The first is disk-based data transfer. You send your data as files on encrypted USB disk to an Oracle transfer site. Now please note that in this case, the disk is yours. So the operators at the transfer site are going to upload the files into your object storage bucket. And as I mentioned, this solution will require you to purchase the disk that is used to transfer the data to OCI. And after the data is successfully uploaded, the disk will be shipped back to you. The second is appliance-based data transfer. In this case, the storage appliances are provided by Oracle. You don't need to purchase any hardware. And the third is appliance-based data export. So here, you can transfer the data that is there in your OCI object storage bucket to your data center. Even in this case, Oracle is going to provide the appliance. Now, one recommendation from OCI is to consider using disk-based data import if the quantity of data that you are importing is 34 terabytes or less. Let's now look at data transfer appliance and data transfer disk. The data transfer appliance service uses a high capacity storage appliance that you loan from Oracle for a short duration of time. And why do you do that? Basically to facilitate data migration to the cloud. The transfer appliance is especially useful when you need to migrate a large amount of data. So please note that here you can transfer between 50 terabytes and 95 terabytes per appliance. The transfer appliance exposes an NFS mount point. You can copy the data to the transfer appliance using normal file system commands that copy data to an NFS target. All data is encrypted as the data is copied to an import appliance. And Oracle is going to erase all of your data from the import appliance after it has been processed. The eraser process follows the NIST standards. The data transfer disk service allows a customer to use their own USB drives and send transfer package to an Oracle data transfer site. Now the site operators are going to upload the files into the organization's object storage bucket. After that, the users are free to move the uploaded data into any other OCI services as needed. Even in this case, the eraser process follows the NIST standards. Alright, this marks the end of this lesson where we discussed the data transfer service. Thanks for watching. Welcome to this lesson on disk-based data transfer. Let's begin. So let's have a look at the high-level steps involved in performing a disk-based data transfer. This solution requires you to purchase the required number of hard drives to migrate your data to OCI. You have to install Data Transfer Utility for running disk-based data import jobs. After copying your data to a transfer disk, you can generate a manifest file using the Data Transfer Utility. You will then need to ship the disks to the specified Oracle data transfer site. After the data is copied successfully to OCI Object Storage, the hard drives are shipped back to you in the same encrypted state that they were received. Let's look at some of the disk-based data import concepts. First, we have a concept of import disk. An import disk is a user-supplied storage device that is prepared to copy and upload data to Oracle Cloud Infrastructure. You copy your data to the import disk and ship it in a parcel to Oracle to upload your data. Now, disk-based data import supports external USB 2.0, 3.0 hard disk drives. Next, there is a transfer disk. It is the same as import disk, just that the transfer disk is used in the context of configuring the disk, and the import disk is used when physically handling the disk. There is also a concept of transfer package. Ultimately, you will be shipping the parcel containing the transfer disk to Oracle to upload to OCI. The transfer package is the logical representation of that parcel. And you create a transfer job inside the OCI console, which can contain one or more transfer packages. So it logically represents data migration to OCI. Oracle provides a software which is known as Data Transfer Utility. You can download this command line software and it will help you to prepare transfer disks and also manage packages as well as jobs. Once your disk reaches Oracle transfer site, the operators will upload your data to an object storage bucket in your OCI tenancy. A data host is where you store the data that needs to be copied to the disk, which is sent to Oracle Cloud Infrastructure. You can have only Linux machines as data hosts. An Oracle staff needs authorization to upload your data from the transfer disk to your bucket in OCI. For that purposes, you create a temporary IAM user and you must delete this user after the upload completes. This is your data transfer upload user. This marks the end of this lesson where we looked at how we can perform a disk-based data transfer. Thanks for your time. Welcome to this lesson on appliance-based data transfer. Let's get started. In case of data transfer appliance, the appliance is provided by Oracle. However, please note that the data transfer appliance availability is based on inventory per region. Oracle distributes appliances on a first-come, first-served basis based on customer request. Appliance-based data import is one of the Oracle's offline data transfer solutions that lets you migrate petabyte-scale datasets to OCI. Operators at the Oracle transfer site upload the files into the designated object storage bucket in your tenancy. You are then free to move the uploaded data to other Oracle Cloud Infrastructure services as and when needed. In the previous slide, we discussed data import using appliance. Now let's discuss appliance-based data export. Let's say you have some data which is there in the object storage in OCI. Now you would like to move that data to your on-premises data center. So you can use appliance-based data export. In this case, you will be able to retrieve the data from object storage more quickly than using the public internet. For example, you may have media assets or processed data sets that need to be shared with a client or business partner. Now let's look at some data transfer appliance import concepts. You can use a secure, high-capacity Oracle-supplied storage appliances at no cost. And when I say high capacity, it provides up to 50 to 95 terabytes per appliance. You request an import appliance from Oracle, copy your data onto it, and then ship it back to Oracle for upload. After Oracle receives and approves your request, a transfer appliance will be shipped to your address that you specified when creating the request. You now need to download the OCI CLI toolset on a Linux host computer at your site that is running a terminal emulator that can access the appliance serial console. The host computer at your site from which you perform data transfer service tasks is what is known as the control host. And now there is a transfer job and a transfer appliance. Transfer job is the logical representation of a data migration to OCI. If we talk about transfer appliance, it's a high capacity storage device that is prepared to copy and upload data securely to OCI, which means you copy your data to one or more appliances and ship these appliances to Oracle to upload your data. Now let's look at how the data import works in case of data transfer appliance. You create a transfer job of the type appliance using the console and then click Request Transfer Appliance. This is your first step. Now, depending on how much data you want to transfer, you may need to order more than one transfer appliance. After Oracle receives and approves your request, a transfer appliance will be shipped to the address that you specified when creating the request. When you receive the transfer appliance, physically connect the appliance to the host computer with the provided USB serial cable. You also need to power on the appliance, configure the transfer appliance networking, and then physically connect the appliance to your network. You then need to initialize the transfer appliance using the OCI CLI. Initializing the appliance sets up communication between the host computer, and remember, this is where you installed the CLI and the transfer appliance. You then need to initialize and configure data encryption. Next, create the datasets and NFS mount points that is needed to write data to the transfer appliance. Sealing a dataset stops all writes to the dataset. The sealing operation generates a manifest across all files in the dataset, and the manifest is going to contain an index of the copied files and generated data integrity hashes. Ship the appliance back to the Oracle transfer site. You can track the status of your transfer appliance using the console or the CLI. Oracle will update the status of your transfer job and the transfer appliance. After Oracle receives your transfer appliance and uploads the data, a detailed summary is generated and posted in the same object storage bucket where the data was uploaded. This marks the end of this lesson where we looked at how we can perform an appliance-based data transfer. Thanks for watching. Welcome to this lesson on Storage Gateway Service. Let's begin. Storage Gateway lets you connect your on-premises applications with Oracle Cloud Infrastructure. Applications that can write data to an NFS target can also write data to the OCI object storage, and the best part is you don't need to worry about application modification to uptake the REST APIs. So in a way, Storage Gateway is a tool to move data from on-premises to OCI. Using Storage Gateway, your applications can interact with OCI object storage through standard NFS version 4 protocols. And Storage Gateway is going to perform the NFS to REST API translation that is needed to interact with OCI object storage. Storage gateway can also cache frequently retrieved data on the local host, minimizing the number of REST API calls to storage gateway and enabling faster data retrieval. So as you can see here, storage gateway exposes an NFS mount point that can be mounted to any host that supports an NFS v4 client. And the storage gateway mount point, it maps to an object storage bucket. So on the left, you have the on-premises application that can write to an NFS target. On the right, you have the OCI object storage. In addition to uploading to buckets in object storage standard tier, storage gateway supports uploading to and restoring objects from buckets in the archive storage tier. And in the center, you see the storage gateway using which you can connect on-premise applications with OCI. Storage gateway exposes an NFS mount point, as I mentioned, that can be mounted to any host that supports an NFS v4 client. So there is file to object transparency between storage gateway and object storage. And a storage gateway file system directory on a local host is going to map to a bucket with an identical name in OCI object storage. Now let's talk about some storage gateway concepts. In storage gateway, we can create a file system. Any file written to a storage gateway file system is written as an object with the same name in the associated object storage bucket. So you configure the cache for the file system when you create the file system. When you retrieve data from OCI object storage, the data is stored in the storage gateway read cache. The read cache is going to allow subsequent I/O operations to that data at local disk speed. And when an application transfers files through an NFS share, the files are written to the right buffer. And that is going to facilitate asynchronous movement of data to OCI. NFS lets client computers mount file systems on remote servers and access those remote file systems over the network as though they were local file systems. In this case, the storage gateway performs the NFS to REST API translation, which is needed for interaction with OCI object storage. When you create a file system, you specify the storage tier in which to create the corresponding object storage bucket. The default standard object storage tier is used for storing the data to which you need fast, immediate, and frequent access. And archive storage tier is used for storing data that is accessed infrequently and requires long retention periods. Now let's look at the high-level steps when it comes to installing and configuring a storage gateway. So first, you have to download the storage gateway software, and the OCI storage gateway download includes an installer script to install the storage gateway. The storage gateway installation software is going to automatically install Docker and the NFS. You require Oracle Linux 7 as Oracle Linux 8 is not supported. After you have downloaded, you then need to extract the files from the tar archive and then run the installation script. After a successful installation, the script will provide you an URL using which you can log in to the storage gateway management console. And this console is going to use the port 32770. When you log into the management console for the first time, a wizard is going to prompt you to create the administrator credentials and then your first file system. You also need to provide information like compartment, tenancy, and user OSIDs, as well as private key and public key fingerprint. This is required to connect your storage gateway file systems to OCI. Then you need to connect the file system to an object storage bucket to store and retrieve data through the file system. And each storage gateway file system is going to map a directory to an object storage bucket. To establish the connection between the storage gateway and an NFS client, you must mount the storage gateway file system on the NFS client. Now, you need to verify that when you write a file or a directory to the file system, it creates an object with the same name in the bucket. Now let's look at some of the use cases. First, we will focus on hybrid cloud scenario where your on-premise applications can use object storage for storing data, and there are several benefits associated with it. First, you save on the costs, and then you get limitless storage. Storage Gateway is also ideal for data migration and provides an efficient tool for moving data from your on-premises data center to OCI. Storage Gateway tiers data by asynchronously moving hot and cold data to the cloud. So data migration basically means you move data from your on-premises host to OCI. Cloud tiering basically means that you expand the capacity of on-premises storage solutions without capital expenditures. Then there is also a use case on backups where you can move files to OCI archive storage as a cost-effective backup solution. And then there is also disaster recovery, which basically means that Storage Gateway lets traditional applications move data to highly durable object storage. And when you need to recover the data, you can create a fresh instance of Storage Gateway to return the data from object storage. This marks the end of this lesson on Storage Gateway. Thanks for your time. Welcome to this demonstration on Storage Gateway. Let's get started. I'll take you to the OCI console, and first of all, let me walk through what I have already created for this demonstration. So you can see that I currently have two different VMs that are running in Sydney region. The first is Storage Gateway, and then we also have a client machine. I have created this Storage Gateway demo VCN, and inside this VCN, I have created a public subnet with the name Storage Gateway Demo Subnet. I've also created an internet gateway. So you can see here, if the destination is this, the target type is internet gateway. What I have also done is, if you go to the security list and click on default security list, you can see that the initial three are the default rules. The last two rules is what I have also created. That means I'm also opening up port 32770 and 32771. And in the subsequent steps, you will understand why I have done this. And if I go to this, the user with which I am logged in, I have also added an API key. So you can see the fingerprint, and I have also generated a key pair. So this is what is done. So now let me show you how you can install the Storage Gateway. So let me connect to this VM Storage Gateway. So I'll use PuTTY for that. So let me just type 152.67.97.87, and I will provide the private keys. This is the private key. I'll click on open. So this is asking for login as. I'll specify OPC as the username, and you see I am now connected. Now let me show you from where you can download this Storage Gateway. So if you go to this page, you see there is an article downloading Storage Gateway. If you further scroll down, this is the option, download the Storage Gateway tar archive. You click here, click on all supported platforms, click on iReview, and just download this. In my case, I have already downloaded it, and I have used WinSCP to copy it to this particular VM. So if I open up the putty and just do an ls, you can see this is what I have downloaded. So now I will just run this command. I'll change the directory. So now you see we will run this particular command. Type yes. So this is done. Type Y. Now it's going to ask the location for installation. I'll press enter. Now it is asking for the location for the file system cache. Now it is asking for the metadata location. Now we have to provide for the log storage. So you see that the storage gateway installation is in progress. All right, so you see that this is successfully completed. Now you are able to see the management console, which is https storage gateway colon 32770. And this is basically the NFS port. We'll try to open this management console. All right, so click on advanced and click on continue to this site. So this is how this console looks like. It says welcome to OCI storage gateway. Now you have to create a new password. I'll quickly create one. I'll click on save. Now you need to provide the password to login. So now you are inside this management console. So let me create a file system. I'll click here. Let me give the file system a name. I'll call it on-prem files. And then you have to select the object storage tier. I'm okay with standard. And because we are in the Sydney region, you need to select appropriate object storage API endpoint. So just click here. It will show you a list of the endpoints. And because we are in Sydney region, so we'll select the endpoint for Sydney. This is the one. So go back and provide the object storage endpoint. Now it will ask for details like compartment OSID. We are using migration demo compartment. So I will provide the OSID for that. I already have these details. Similarly, tenant OSID, the OSID for the tenancy, the user OSID, and it's asking for the public keys fingerprint. So here, when you add the API key, it generates a fingerprint. So I'll just copy this and I'll put it here. And now it's asking for the private key. So I will just provide the private key. Okay. Let me click on save. You see that it says creating on-prem files and on-prem files created. Now let me click on connect. In the timeline, you can see that it is currently connecting on-prem files. It says connected on-prem files. So if I go to the bucket, I should now be able to see a bucket in the Sydney region in OCI with the name on-prem files. and you see the default storage tier is standard. So click on on-prem files. So I will return back to this management console. Now, if I click here, you will be able to see the NFS client mount command. So now let me connect to this client machine that has this particular public IP address. So now this is going to be the IP address. I'll specify the private key file. Click on open. You see it is asking for login as. I'll specify OPC. First of all, I will create a directory, my app data, and then I am going to use this particular command. And here, this port, if you remember, it was 32771. And then this is going to be the local mount point, my underscore app underscore data. So I'll click enter. All right, so this is now done. If I run this particular command, you can see that this particular file system is mounted on my app data. So let me now go to my app data. Okay, I've created this sample file. All right, so if I go to the buckets now, if I just refresh it, I can see that sumbit.txt is now created inside this on-prem files bucket. All right, this marks the end of this demonstration on Storage Gateway. Thanks for your time.
Hello everyone, welcome to this next module. In these lessons, we are going to discuss about migration of another core component in your tech stack into OCI, that is database migration to OCI. As a side note, all the lessons covered in this module are primarily focused on migration of source Oracle databases into Oracle Cloud Infrastructure database services. What we learn here is more like a getting started content where you get some insight into how to achieve your Oracle database migration into OCI database services. For a detailed understanding of Oracle database migration into OCI, please look for the dedicated learning course on database migration from MyLearn. Before getting to learn about Oracle database migration into OCI, let's just discuss briefly what does database migration mean in general. Database migration could mean an environment change where you move your source database into a different environment, like moving from on-premises to cloud, moving to a different storage hardware or to automatic storage management solution, or to a different OS platform with the same or different NDNS. Example, Windows to Linux migration. You may choose to change the database character set for globalization support, like changing to AL32 UTF-8 Unicode character set. Enterprises understand the benefit of multi-tenant feature in Oracle database, so they may choose to move from a non-container to a container-based architecture. Or it could mean to move from one database type to another, that is moving from non-Oracle database type to Oracle. Usually, migration projects are driven by certain business goals that an enterprise wants to achieve, and in here we would be discussing in the context of database migration. Here I have listed a few of them, but it may grow depending upon the enterprise needs. Firstly, it may be an organization mandate to do away with the legacy systems and modernize infrastructure with advanced technology to be able to sustain the growing market competition. Enterprise should have an agile database development platform that would enable rapid development and delivery of data-centric applications, which can be launched much faster than before. It would provide a competitive edge over its rival and foster higher business growth. The response time of an application would decide the affinity of its end users. Hence, the need to move databases to a high-performing database system is highly desired. Enterprises may have multiple database deployments where the resource may be overutilized while some of them may be underutilized, and that simultaneously can affect the cost. Migration in such scenarios can help to consolidate deployments so that resources and cost can be optimized. Another big concern around migration is like to be able to perform the task with least impact on business. So migration has to be carried out in a way to cause least downtime to your applications. Migration is also planned to bring down the overall cost due to capital or operational expenses on resources that are simply redundant. There are several considerations that come into play when choosing a target database type, like whether the required feature are available, what kind of automated features does it provide, to what level it can reduce the database management effort, the data security features of the database, how about availability and the DR features, and the cost aspects. Let's now discuss on the technical considerations to be taken into account when planning a migration. We look into the source and target database type. Are both of them same or heterogeneous? We look into the source and database type. Are both same or heterogeneous, like Oracle type or are non-Oracle type? Based on that, we need to assess the feasibility, the best method to use for migration, the amount of effort and the skills needed, and an estimation of the duration of the entire migration task. We need to know the version of the database, check if the source database types are compatible with the target database. Even the size of the source database matters as it can decide the duration of the migration. You need to choose a faster data transfer mechanism to the target database environment in order to lower the entire migration task duration. Then depending on the source database type, you need to calculate the time and effort required to do the equivalent conversion of source database routines into the target database environment. You must also have a good network bandwidth between your source and target database environment for faster file transfer. And more importantly, whenever you plan your database migration, make sure you have a well-tested fallback plan. Else, if the migration attempt fails, it may cause severe impact on your business due to unavailability. Additionally, there are a few other considerations when your source and target database types are Oracle. You need to know what all options are active in your source database so that those options are enabled in your target environment. Next, does your source database use multi-tenant feature? If it is a non-container database, then you can convert it to container database as part of the migration task. You also need to check the OS Indianness and version being used at the source Oracle database platform so that you can check its supportability in the target environment. What is the source Oracle database character set so that you can set it to the same character set or to the Unicode character set in the target environment. Is the data encrypted at source? If yes, then how are you going to migrate an encrypted database into the target environment? What are the current database disaster recovery configurations enabled at source, and how is it going to be achieved once you migrate into the target environment? There are several reasons when a migration attempt may go unsuccessful. As per industry observations, 50% of the migration projects execution exceed budget and 83% of the migration fails due to poor migration strategy and they miss the planned timelines. Hence, a precise planning for migration is very critical to its success. Let's discuss briefly on some of the elements that you can take into account while planning your migration. Understand the data you want to migrate, their dependencies, compatibility with the target database system, whether you should migrate a portion or in entirety, its size and all such attributes. Internally, you should collaborate with all data owners explaining about the migration plans, the benefits it can bring in, the project timelines, the downtime, operational changes post-migration so that there is a consensus among the stakeholders and there is no pullback once agreed. Evaluate the efforts needed, how many resources are needed, new expenses to be borne, project hours to estimate the budget size for the migration project. Identify resources who have good technical expertise with database migration. Set up a project plan detailing the migration sources, appropriate method to use for migration based on the source and the order of execution and the timeline for completion. Perform migration dry run on non-production environment on an equivalent size of production data. This will point to any issues that may arise during migration so that you can resolve such issues and apply the same resolution during actual production database migration. Prepare and test a fallback plan for every migration in order to revert back to original state if the database migration fails by any chance. Security of your database should be kept intact in the new environment as before migration in the source environment. Hence, you must prepare a list of data security settings and the compliance rules that must be replicated into the target environment. These are few of the recommendations that you should consider while creating your database migration plan. Now, when it comes to choosing the target database migration deployment platform, Oracle Cloud Infrastructure has been the choice of several enterprises to be highly reliable environment for various reasons. OCI deployments reduce enterprises' overhead of managing infrastructure and its operations to a very large extent by providing simple and easy to use management tools and interfaces, benefiting them to focus more on their business growth and innovation. OCI's Gen 2 architecture makes it more robust platform in terms of performance, availability, and management of the services. You can take advantage of the core OCI services to create a highly available deployment platform and avoid any single point of failure. It allows you to scale your compute and storage resources on demand, which can be online and may incur small downtime depending upon which target OCI database service you choose. OCI is highly secured by design and complies with 80 global, regional, and industry security standards. It has several built-in security features to protect your database deployment in OCI, which includes data encryption, key management, data masking, auditing, activity monitoring, user access controls, etc. OCI operations are entirely driven by automation. Most of the operations such as provisioning, monitoring, patching, availability, security are automated, which entirely simplifies management without any manual intervention. OCI is versatile in its list of service offerings across different service layers, and at the same time, most of the services are integrated. It relieves you from performing any configuration in order to integrate between the services. To wrap up on this lesson, the sole objective was to give you a basic understanding of database migration and what are some of the business drivers for database migration. We understood about some of the technical consideration that needs to be analyzed and other recommendations to be taken into account in order to prepare and execute a successful database migration project. I hope this was helpful. Thanks for watching. Hello and welcome again. In this lesson, we are going to discuss about the different database services available in OCI for you to choose as a target database for migration. Let's begin. OCI offers different database services, but which one you have to choose is based on your enterprise requirement. The database services can be classified into different categories. OCI offers database services which can be entirely managed by Oracle, and the customer is only responsible for managing the data. It's the fully managed database service option. If enterprise wish to take ownership of some of their database management tasks to meet their business requirement, they can choose the co-managed database service type. Then enterprises also have the flexibility of deployment choice. They can choose to either deploy in public cloud, which is highly secured, or may choose the OCI Clouded Customer option, which allows the cloud deployments to reside within their firewall and also comply with the data sovereignty law of the region. Looking into the different database services in OCI, relational databases in particular, we have Autonomous Database and MySQL HeatWave, which are fully managed database services. And then there is Exadata DB and BaseDB, which are co-managed database services. In this module, since the target migration database is Oracle, so our focus would be only on the Oracle database services. However, please take a look into our MySQL HeatWave course, which covers in great detail about this service. Let's now have some overview on each of the different Oracle database service types. There is Autonomous Database, which is a fully managed database service in OCI. Simplest and fastest to provision within few minutes. It is highly available, self-secured, and automatically recovers from failure. It can self-tune itself, auto-patch, and auto-backup your database. It can scale up to a large capacity, or you can enable auto-scale up to 3 times of the initial size of compute and storage on demand, and it is entirely an online operation. Autonomous database comes in different flavors, optimized for specific workload types. For OLAP workload, you can choose Autonomous Data Warehouse. For OLTP, choose Autonomous Transaction Processing. For JSON workload type, choose Autonomous JSON. And for supporting Apex development, you can provision Apex service. You may choose the deployment option based on your requirement. You can choose to deploy Autonomous Database serverless, which will provision Autonomous Database in a shared infrastructure in OCI. This does not mean your database is open for public access. Instead, in this type of deployment, only the Exadata infrastructure is shared with multiple customers with strong isolation and no overprovision. If you wish to have more control on your Autonomous Database infrastructure, then you can choose Autonomous Database in a dedicated infrastructure. And if your enterprise business is restricted by data sovereignty laws, you can choose Autonomous Database Service in Exadata Cloud Customer. Next, we have Exadata Database Service, which is a co-managed database service but delivers very high performance. Oracle manages the Exadata infrastructure and database service components, while customer manages their database lifecycle in the infrastructure. It supports Autonomous Database provisioning, in which case it becomes a fully managed service, or you can provision Oracle Database Enterprise Edition Extreme Performance with version 11.204 and above. The deployment can be in dedicated Exadata infrastructure in OCI or Exadata Cloud Customer. Then we have the base database service, which are again co-managed Oracle Database Service. They are hosted on VMs and Oracle just manages the infrastructure, and customer manages the entire lifecycle of the database and the system using consoles, CLI or Oracle Enterprise Manager. It provides you the choice of different editions while provisioning, like Standard Edition 2, Enterprise Edition High Performance, and Enterprise Edition Extreme Performance, which differ in terms of the enabled database options. You have the option to choose from various SIPs, which can be Intel, Ampere 1 and AMD based. You may choose standard or flexible SIPs. In case of base DB service, you can provision single node or real application cluster with only 2 nodes. To wrap up on this lesson, this was a short overview on the different database services which are available in OCI and the flexibility of deployment options you have to suit your organization needs. You may either choose a fully managed option to do away with the regular maintenance and management tasks, or choose a co-managed service that gives you some control for customizing your operations. We have limited coverage here, but I recommend you to go through the dedicated courses on these different service types to get a broader understanding of their capabilities and the significant benefits they can bring to your application database deployment in OCI. I hope this has given you some initial understanding of the different OCI Oracle Database Service, and it would be helpful to you. Thank you. Hello and welcome back. This lesson is meant to give you some inputs that can help you choose the right Oracle Database Service in OCI